Hello, my name is Hrishu Devulapalli, and this is my Lab 1 video for my Lab 1 project. All right, so I'm going to be discussing four types of circuits. One is a half adder, one is an increment, and one is a full adder, and one's a 4-bit full adder. So let's go with our half adder. So over here's a half adder. A half adder adds two 1 bits in a 1-bit binary. So either A is one, either B is one, or either both or are zero. So let's look at how the logic works. Over here we have an XOR gate. An XOR gate only does either or. So either A is true or B is true, then it'll do it. If both A and B are true, then the sum won't show. So we can see here we add A is one, B is zero, one plus zero is one, and the XOR gate turns active, and we can see the sum is showing. However, when we add both of these together, since the XOR gate does not accept two does not accept two of them to be true. The XOR the sum won't show, the sum will be zero. And since this is an AND gate, the carry out will be active. So how an AND gate works is if both A and B are switched on, the AND gate will be turned on. So the carry out will be one. So if you were to do like 1-bit binary, it would be one plus one, then you would have zero, and then you would carry out the one. So let's look at this in our GTK wave. So as we can see, we have our variables over here. We have A, we have B, we have our outputs, the carry out, and then we have the sum, all represented through a GTK waveform. So let's move on to our incremental. So over here we have our incrementer. An incrementer basically has four half adders. They've been condensed into these boxes for like simplicity. So how an incrementer works is you have one variable, which is A, and this is in a 4-bit system. So how the regular half adder was just 1 bit plus 1 bit, this is now 4-bit. So now it's going to be a 4-bit binary. So how it works is essentially the incrementer, it represents just a 1 bit, either one or zero, as we can see with the output Y. This is a 4-bit. So the maximum it can go is till F. And when, let's say we have input A as 4, and then we do 4, and then we have an incrementer over here, and then we do 4, and then plus 1 is equal to 5. So increment is either 1 or 0. So with an incrementer, we can essentially add plus 1 to a 4-bit binary. And if it overflows over here with the carryout, oops, look at that. Now the carryout is turned on as 1 because 15 plus 1, 16, that goes overboard a 4-bit binary system. All right, now let's go and put that on GTK Wave. So literally all this is just four half adders. If I were to put this on GTK Wave, we have our inputs A and B, and then we have our outputs, which is the carryout and the sum. So over here, this is how we can look at it on a GTK wave. So this is how this a 4-bit increment will look on GTK Wave. So I'm moving on to a full adder. So over here is a full adder. A full adder in a 1-bit system, similar to how a half adder works. However, now we have a carry in. The carry in essentially adds is like another variable. It can either be 0 or 1. Um, you can carry in a 1 or not carry in a 1 in case it's going to be 0. And just like in a half adder, we have an XOR gate, and the XOR gate in this time, it only works if an odd number of inputs are present. So let's say if 1 is there, it'll work. If 3 inputs are there, it'll work. However, if there's 2 inputs, it won't work. Then the sum will be 0. However, the AND gates work if all inputs are present. So in this case, A and B are active. So this AND gate with those 2 inputs is going to be active. And this OR gate, which needs any input, it doesn't matter if it's 1, 2, or 3 inputs, it'll be active. And that's how we will have a carry out of 1. So imagine like our sum, we add 1, 1, binary, it'll be 0, and then we carry out a 1. Then we have a carry in, we have a 1, 1, 1. We add those 3, we get a sum of 1, and we get a carry out of 1. So that's how a full adder works. On GTK Wave, we can show this. So over here, we have a full adder on GTK Wave. We have our 3 inputs, A, B, C, and then we have our 2 outputs, carry out and sum. So here's how a full adder looks on GTK Wave. And last and not least is going to be our 4-bit full adder. Like the name implies, a 4-bit adder is essentially a 4-bit version of a full adder. We have, so now it's in a 4-bit system. So now A and B can be represented like can be values as long as it's like within like a 4-bit binary. So like anything like less than 16. And now we have a carry in. The carry in is going to be the same as it was in the regular full adder. The carry in is essentially a one or zero. Let's say I add 2 binary like 1, 1. I get a 0 for my sum, and then I carry in, and then I carry out the 1. Then like for the second place of the binary, that 1 that I carried out in the first place will go in the addition. For example, let's say I have this is equal to like 7. Let's say I have this equal to 1. Now, if I add 7 plus 1, it'll be 8. And over here, there is an overflow. And over here, there's an overflow. And the overflow is actually represented through an XOR gate. And so the XOR gate only, so like, and so for how an XOR gate works is it needs only one output. If this output and this output are both active, then the XOR gate will not be active. And there won't be an overflow. So as you can see over here, I put B as F. And it's essentially 15. And now if I were to add both of these values, even like with the carry in, as you can see, the sum does not actually represent the addition because it now is going out of bounds. It's going over the bounds of a 4-bit, which maximum is going to be like 6. It's going to be like 15 represented like in a 4-bit. And so the some will not be indicative because there's a carry out that's taking place. So here is how a 4-bit adder works. And yeah, so for the yeah, and then so as yeah, so the 4-bit full adder is essentially just four full adders, and then the overflow is represented using an XOR gate. Only one of these inputs needs to be active for the XOR gate to be active. All right. So here's how we so okay, so here's the GTK wave of this circuit. So literally it's just four full ladders. Just like how we discussed with the full ladders, we have three inputs, the A, B, and the carry in. Then we have two outputs, the carry out and the sum. So as we can see, here's a GTK wave representation of how a full 4-bit full adder should look like. Um, Thank you for viewing my presentation. I hope you guys like it. I hope it was informative and um yeah, I'll yeah, and yeah, thank you for viewing my presentation.